Namaskar. I'm Harpreet Kaur and I welcome you all to our live and interactive session on virtual labs. You are watching us live on PM eVidya channels 6 to 12 and also on our YouTube handle NCERT Official. Well, today we have brought this session specifically for the students of class 11 and the subject that we are taking up in this session is physics. The topic is going to be demonstration of simulation on parallelogram law of vectors. Now, if you're a science student, I'm sure you must have understood this concept in your classroom. But if you haven't understood it there completely, there is yet another chance for you to brush up your skills in this session of virtual lab. So let me tell you first of all about virtual labs. What virtual labs are? There are many of you who are wondering why are we having this session and how we can actually perform simulations in a virtual environment. Well, it's quite possible because when it comes to real physical laboratories, it's difficult at times to perform these simulations because of so many reasons. Sometimes we have dearth of resources, we have time constraint, and at times also we do not understand it at one go. So in order to go prepared to the physical laboratories, we can practice these simulations on virtual lab. Now here I want to reiterate that virtual labs are not replacement of physical laboratories. They give you an ease, a platform where you can perform simulations a number of times at your own time, pace, space, and convenience. All you need is a stable Wi-Fi connection or internet connection and any IoT device. There's a lot of content that you can practice. It's not just about the higher classes. We have content available in different languages from classes 6 to 12. And today, since we are catering to class 11, all the students out there who are watching us right now or any member from the general public who wants to know more about virtual lab can participate in the session. Our phone number is 8800440559. Our email ID is diksha.training@ciet.nic.in. And on our YouTube handle NCERT Official, you can send us your questions, suggestions, and your feedback. Well, there is a feedback form available in the virtual lab app as well. What's exactly that? And let's try to access all the features of virtual lab through this session. And for that, I'm joined by my expert who will throw light on this. So please join me in welcoming my guest for the session, Dr. Uma D. Sharma, academic consultant from CIET, NCERT, New Delhi. Ma'am, namaskar and very warm welcome to you.
Thank you.
So, ma'am, I have already briefed all our viewers regarding virtual labs, but today I think it's a very important topic for class 11 students because this is the first class or first step where actually take up science as the main subject. And if they can understand the concepts really nicely at this level, they can pursue it in the higher realms as well. So, the topic that we are taking up today, ma'am, is a demonstration of simulation on parallelogram law of vectors. So, there are two terms, law of vectors and parallelogram. I want you to make us understand what exactly we're going to learn today and what is the relevance of this topic for class 11 students.
Sure, ma'am. See, parallelogram law of vectors, basically it is how we add vectors. Okay, so it's vector is that quantity which specify both magnitude as well as direction. It's not like simply we are adding like distance. Suppose 20 meter plus 30 meter, it's 50 meter. It's very simple to add distances or scalar quantities because it does not have any direction component over there. But when we come to suppose this kind of physical quantity like velocity, acceleration, vector quantities, in this case how we add these vector quantities because it possesses both magnitude as well as direction. So how we can add these quantities? So for that, this is a law which is called parallelogram law of vector addition, and it simply states that if suppose we have two vectors, okay, suppose we have two vectors, vector p and vector q, which are aligned at a angle theta. Okay, so and both are in a separate direction. As you can see, one is along x-axis and one is along simply, it is not exactly y, it is simply at certain angle. So whenever this kind of vectors are there, first thing we have to do, we can resolve it. We have to resolve it along x-axis and along y-axis. It has two components along x, one component along x-axis and one component along y-axis. One way is that either we resolve all these kinds of component and then we add as per the direction. Suppose P, this is along x-axis and the component of q vector is along qx, which is also along x-axis. We can add these both because both are having same direction, and all the vectors which are in along y-axis we can add those vectors. So this is a like little bit lengthy addition method. So instead of that, what we are doing, we are using this parallelogram law of vector addition. So suppose these two vectors, as I have shown, this vector p and vector q, and both are aligned at, both are originates from the common point. This is the one thing, both are originates from the common point O in this case, and the angle between them is theta. So if we construct it in this form, like in a parallelogram, because previously students till 10th they know about the parallelogram, they know about squares, diagonals, so it is related with this parallelogram structure. So you can see this, if I extend it, this result, this diagonal like this, and this is a parallelogram, right? This is a parallelogram. So the diagonal of this parallelogram represents its resultant. That means the resultant of this vector p and q is represented by the diagonal, that and which represents both its magnitude and direction. Means in another sense we can say that if we add both p and q, we will find this r value. Okay, so we can so mathematically we can derive it, and the formula which we obtain for the magnitude of this resultant r is root over p square plus q square plus 2pq cos theta, and the angle, because it is a vector quantity, so definitely it has magnitude as well as its direction, and always we take direction from the x-axis. This is x-axis. Okay, so it makes an angle how much, beta, from the x-axis. So this angle is given by tan inverse q sin theta upon p plus q cos theta. So simply by using geometry, we can derive this formula. There, what is r? Simple by trying this Pythagoras theorem and this tan theta value, we can easily find out the value of this resultant and beta. And what we are doing, this experiment basically explains about verify this law of a vector addition. So we can verify it, and this is a theoretical part. Like theoretically, we can calculate resultant by this equation, and angle, if we this angle by using simple, if I know the value of theta, I can simply find out this resultant angle also. So this is what is called direction. Plus one more thing, important feature of this experiment is that we can see how the different forces when acts on a single point, so how the equilibrium takes place and what are the conditions for the equilibrium, and how the forces get resolved. Suppose in the same thing, when we see in this in the theory part, I will explain the setup, which is in the gravesand apparatus, and the three vectors are acting at one point. So at this point, at the equilibrium condition, all the three forces get balanced. That means P plus Q plus one of this force all get balanced at the equilibrium condition, and their net force which is acting is equals to 0. As we know about the Newton's second law, the net external force acting at a point is 0, then it is in a equilibrium condition. So this also explains about the equilibrium condition of the at a certain point. Now we can proceed how we can do it.
And now that we've understood the theory here, you said that we can also learn it through virtual labs.
Yes.
I want to understand, ma'am, where we can access these virtual labs, and is it free for everybody? Is it really required for us to sign up?
Yes, it's a one-time sign up only. So if you have already enrolled with your Gmail account, so easily we can sign it. Okay. So for that, what you have to do, simply go to the diksha.gov.in, and there you will see one of the vertical this virtual lab.
Okay.
This virtual lab, and here all the these practicals are available from grade 6 to grade 12, and as I told you, it is of grade 11th.
Yes.
So simply we go for this English medium, this physics, and see one-time logging is here. So I have already logged in with the Google.
And it's free of cost.
It's free of cost. Only you have to enroll with your Google account or some other account. Okay. So continue, and you will see this experiment. This is a
table of contents.
Table of content is there, and this is a fifth experiment. And here, from here, this first part is the experiment, to see how this experiment, the entire, which is aligned with the CBSE, what is the aim of the experiment, what we are doing, because it is one of the applications. Suppose you want to know the weight of unknown weight, okay, weight of any stone or any wood part, Okay, so which you cannot measure by the measuring cylinder or any other device. So we can use this parallelogram law of vector addition, and by knowing with some known weights, we can easily find out this value. Okay, so that we are doing over here. So this is the aim of this experiment: measure of the weight of a given body or wooden block or steel block or any unknown object using the parallelogram law of vector addition. Apparatus, here we require this grave sand apparatus. So little bit description is over here. This is a simple wooden board is there, and on which there is a arrangement of attaching a A4 sheet paper. Simple, you just stick A4 sheet paper, and this wooden board, at the side of these wooden boards, two pulleys are attached. As you can see, P1 and P2, these two pulleys are attached, and these are the slotted weights are there. Both at both the end, these slotted weights are there. So as we put the slotted weights, the certain force is aligned with this string. You can see this one force is over here, one force is over there, and at the central point there is some unknown weight is there. So here we can see that the three component, as I have already mentioned the theory part, this O is the common point, and this P, this OA, OB and OX, these are the three terminals where the equilibrium exists at the certain point by putting the certain weights. You will see that when you put one weight over here, then it slides down, then you put another weight over this side, then it slides, it get balanced little bit. So we have to put the weights side by side so that it get balanced with the unknown weight, and once it is balanced, it comes in the equilibrium condition, right? So you can see this over there, and using this one mirror strip is required. Okay, so this is this is the resultant part which I have already explained.
Yes.
R equals to root over P square plus Q square plus 2PQ cos theta. Theoretically, we can calculate over here, and experimentally simple by measuring the length of this resultant, we can easily calculate it. This is a observation table for measurement of weight of a given body. So this is a theory. This PDF is there. I'm directly going to this how we conduct this experiment through the simulation part.
Okay.
See, this is okay. So the theory is already there. Objective, the parallelogram law. So this I want to show. This is a grave sand apparatus. Picture of grave sand apparatus. And suppose this stone, we have to add this stone at some construction site or some point. So, but we don't know its weight. So to know its weight, simply we can, with this pulley system at the equilibrium, we just make it at the equilibrium condition, and with this simple law, by making a this parallelogram at certain point, we can easily by calculating its resultant, we can calculate its value. Okay. So this I have mentioned this at the equilibrium point, all the three forces P plus Q plus Z is equals to 0. So let's start this experiment.
Right.
This is a simulation.
And before simulation, we can also learn more about it through the procedure part and animated video. Okay.
Refresh. I think it's not downloaded right now. Let's refresh.
So in order to access all the features, we can always refresh the tab. And I can see that there is a help button also. So instructions are also given how to perform the simulation. After learning the theory, you can always go to the procedure part. As I already mentioned, there's the entire write-up how to perform the simulation. Then there is an animated video also, because we have different kind of learners who learn differently, and I think the inclusion is best, served like this.
Yes. So as you can see, now it's downloaded. Like sometimes due to the internet issue, it takes some time to download.
So better to refresh the page.
Better to refresh the page, or you can simply close it and start afresh. Okay. So here, see, three objects are there: wood, stone and steel, and here no weight is mentioned over there. We don't know what's the weight of this. So we will take one by one. I will select one object, suppose wood. I want to find the weight of this body. Now you can say the change in the hanging weight. These two are the hanging weights. So simply from the right hand side, I can change this weights like this. You can see this. Okay, so suppose I would just take 60 one side, and another, let's take suppose 60, 70, I have taken 70. Okay.
Hmm.
So you can see now it is not sliding, it's stuck. It is not, otherwise it will start hanging. Okay. So it is steady at one point. So this is the point of the equilibrium, right?
Okay.
Now at this point, I will just write show parallelogram. Okay, show parallelogram. So that means what is that? Simply at this point we have seen this two vectors which are at the adjacent side of this parallelogram. Both have the same origin. OA and OB has same origin. Then as per the parallelogram law of vector addition, it states that the diagonal represents the resultant of these two vectors, sum of these two vectors. Okay, so this, as you can see over there, because this is a normal line, straight line, so this OD balances this force. Okay, so this force, the value of this force is equivalent to this vector.
Okay.
Then only it get balanced, because these two are inclined at certain angle. This is at y-axis, these two are inclined. So if I draw it, you will see that along this axis, like at this point, this is x-axis component is there. Both components are equal and opposite, so they get cancelled, and this y component only, this y component is equivalent to this weight of this object. Okay, now we have to use certain scale as per the weight. The scale which I have chosen is 20 gram is equals to 1 centimeter.
Okay.
Okay. We can take as per the slotted weight. Suppose your slotted weight is of 50 grams. So we can take 50 gram equals to 1 centimeter. These slotted weights are of 20 grams. So I have taken 120 gram is equals to 1 centimeter. So what I will do now, I will use scale, and with the help of scale, I just measure this value, because magnitude part I have to measure like this. This is a graphical portion. Experimentally, how we can calculate the resultant value. One I have already mentioned how theoretically, right now, R equals to P square plus Q square plus 2PQ cos theta square root of, and that is the resultant. That is a theoretically part. Now experimentally, how can I calculate it? Simply from the scale, I just note down the value. This is 0 to 4. It is nearly 4 centimeter. If you see, I will little bit zoom it.
Okay.
So it comes out, I think, 4 centimeter. So 4 centimeter. So 1 centimeter is 20 gram.
Yes.
So 4 centimeter is
80
nearly
grams.
80 gram. So I will write it 80 gram. So this 80 gram is the weight of the object. Let me check. Yes, it is a 80 gram. So this is a one way. Now, if you have to verify ki is it correct or not with the theoretical evidence, what you can do, you can measure this thing, the value of OA also in the same manner. You can measure the value of OB also in the same manner, and you just, with the help of this protector, one protector is given. So I just first of all hide scale. With the help of this show protector, what I will do, I will calculate this value of theta, that is angle between OA and OB. Okay, OA and OB. So once I get the value of this theta, this angle between OA and OB, and also I know the value of OA, also I know the value of OB, I can easily, using that formula, R equals to root over P square plus Q square plus 2PQ cos theta, I can calculate it manually. And we can find that the magnitude comes out to be this much. Okay. Now I will reset it once again, and for the we can repeat it for the stone also. You can see this for the stone. Again we can simply use some other weights. Suppose 80 gram I have taken. Here I will take 190 gram I will take. Then simple show parallelogram. Now it's a little bit goes upward. I cannot measure it. I have to reset it again. This 60, okay, 70. Then show parallelogram. Now again show scale. I will measure it. It comes out to be how much? Again, it is coming.
So we can also zoom it and measure.
We can zoom it and measure it, and suppose it is, I think exactly I'm not able to see, it is 4.1 something.
Let's take any
4.1 into 20. Let's
approximate
see.
Figure.
So 4.1 into 2, so it comes out to be 82. I think 82. Let's check it. Yes, it's correct. 82. Okay. So in this way, we can easily calculate it, the unknown weight, which is the aim of this experiment.
Okay,
ma'am. Now
And you can verify it through the theory also. Now, once we're through with the experiment, and now I want to check, what all I have learned is up to the mark or not, where I stand, whether I can attempt the another difficult level or not. So we have the self-evaluation.
Right.
And ma'am, the self-evaluation, like, does it come with a timer also? Can we also check our speed? In what time are we answering the questions?
No, as such,
Not necessarily.
Not necessarily. As such, no time is there, but we can evaluate what we have learnt, or is there any problem with this?
And I can see this bulb icon also on your right.
Yes, yes. This is for hint. Suppose the students require some help. So he is stuck in between two options, so he can click to the hint.
Okay.
And then it simply explain the answer. Okay. So in the experiment on finding the weight of the body by the parallelogram law of vector, the student needs to use 3 pulleys or 2 pulleys and the 3 weights in all. So once hint is given, gravesend apparatus, so student can imagine, yes, it has only 2 pulleys and 1 weight is there. So accordingly you will answer it. 3 weights,
so
2 pulley and 3 weights and all. Okay, so in this way, so the student can go through the entire this questionnaire. Which of the following is a scalar quantity, to identify whether they know about the scalar quantity or vector quantity, they know about it or not. So here we can see velocity is a vector quantity, weight is a vector quantity, displacement is a vector quantity. So speed is the scalar quantity. So to add these vectors, we required some law, and this is one of the law. There one more law is the triangle law of vector addition, and this is a parallelogram law of vector addition. So, and head to tail method, this is one of another method for adding vectors. Means because vectors we always show by some arrow mark. Okay, that arrow and the length of that arrow is defines its magnitude, and I will show it to you here. The length of the magnitude is simply this is its magnitude, and this is its direction. Direction is because from the x-axis we normally take it. This is x-axis, this is y-axis. So theta is and this is the origin. So we can say that this p is a vector. P is a vector, and having magnitude this much. Okay, and theta is its angle. Okay. Now suppose we have to add two angles. So this is by head to tail method. This is head and the tail of the another vector. So we have to add like this head to tail method, and then find out its resultant by this diagonal part.
Right.
So this in this case also r is the resultant, and its direction should be in the opposite side of this. So this r is the resultant of this p plus q. Resultant means the addition of p and q, and the angle of this r is this, suppose beta.
Okay.
So in this way, these vectors are added.
Right, ma'am. And ma'am, there's one doubt I'm having as far as self-evaluation is concerned. What if I attempt a question and my answer is incorrect? What will happen then?
In this case, when we are doing evaluation, nothing. Once you submit it, then it shows the wrong answer. So person can go through the reference material to study it more, or they can go through the video itself, or any other resource material, like they can go to the PDF, they can go to the theory part of it, wherever that question is taken from. Okay, so once you revise that again, so you can come back to over here and then attempt the same question again.
Right.
I think in that way they have to refine it their own.
Okay. So ma'am, now we're through with the simulation part. We've done the self-evaluation questions also. You're talking about reference material. There are many students who want to study more. So do we have any reference material?
Here certain resources are available.
Yes. Okay. So we have it under the resources tab?
Yes, under the resources tab. It is basically entire materials given in their NCERT this lab manual. Okay, so there they can go through it for the detailed learning. Also, they can go for certain websites are there, like preengineering.com is there, shell is .com is there. So different websites are there where they can go in detail. They can study in detail about this parallelogram law of vector addition with plenty of examples.
That's lovely. And lastly, you can always share your feedback regarding the entire simulation. We have another tab for you. So do let us know what all changes we can make on our page and what all content you want us to include there in this online application tool. So today we learned about demonstration of simulation on parallelogram law of vectors. We understood the theory portion. We saw how to perform it. Now when you will go to the physical laboratory, you'll go prepared and you will get the desired result, and that too in no time. And for this entire journey, let me thank my expert for the session. So Dr. Uma, thank you so much
Thank you.
for your time and contribution to the session. And it was a wonderful session meant for the students of class 11. Of course, the topic was related to physics. So I am closing this session here. But for this week, the journey has come to an end. But next week, we will bring another journey of virtual labs, Monday to Thursday. We will have bilingual sessions on various topics across various disciplines. We request you to kindly be there and ask questions and participate in the session. Now, before I finally quit the studio, let me update you regarding the textbooks. Yes, they are available on Amazon, Flipkart, and NCERT website. You can purchase them from there and simultaneously take a quick look at what's coming ahead. We have the schedule for you. So we're through with the session on virtual labs, and in a short while from now, you can watch a session on inclusive classrooms where the topic is going to be biology, and we'll be talking about biotechnology and its applications. 2 p.m. is the time for the session of science. Heat transfer in nature will be the topic, followed by a session of mathematics where we will learn about number play. 3 p.m. is the time for our session of Sanskrit, and 3:30 to 4 p.m. we will bring you a session of social science. The topic will be Reshaping India's Political Map Part 1. 4 to 5 p.m. is the time for our online training program. This week we are talking about digital wellness, and we will end the day with our session Sahyog. We will talk about turning scars into strength, overcoming bullying experiences. Well, they say that if you want to change your life, change your mindset, and Sayuk sessions are there to provide you that extra psychosocial support which you need at every level. So I request everybody to kindly watch these sessions very carefully, participate with your questions, do give us a call or write an email to us. They are going to be fun activities for all of you. We are looking forward to have your participation. With this, it's a wrap. This is me, Harpreet Kaur, taking leave of you and will join you soon. Namaskar.